All right, we have one of our trickiest topics today with exponential growth on annual growth rates. So just to kind of get your brain thinking here, it says if your bank account increases at a rate of 4% annually, at what rate will it increase over a 5-year period? Okay, so we're really switching our gears into finances. I know you guys take a lot of finance courses, and that's where this exponential growth is taking us over the next week. Okay, so you put money in why do we put money in a bank account? Right? The whole point is that you're going to earn a little interest for the money that you keep in there, right? So you have some interest rate, okay, and they're going to pay you a small percentage to keep your money at whatever bank you choose. All right, now if you don't touch that money, let's say after the first year you have $100 and it's a 4% interest rate, so now you have $104. So now you're going to make money off $104 versus the $100. So every year you should be gaining a little more interest, right? All right, so let's recall our exponential growth and decay formulas. And that's what we talked about yesterday. So we said y equals the amount. If it's growth, it's 1 plus the rate to the time. And we said you can always divide by that frequency. And if it's decay, it's that initial amount, 1 minus the rate to the time. And again, you can divide by that frequency. So example 1, the following exponential function models the growth of a U.S. city where t is in years. The units are extremely important because our Regents exam loves to change the units on us. And I'll show you a couple examples towards the end of this lesson. All right, so given this function, p of t, we should be able to answer all of this pretty handily at this point. What is the initial amount? Again, the initial amount is the a value. We have an initial amount of 1,250, and we're talking about population, people. Is this growth or decay? So we're looking at the b value attached to the variable. This number is clearly greater than 1, so we know this is exponential growth. Okay, that b is greater than 1. And now what is the rate? Okay, so that b value is 1 plus the rate. So 1 plus the rate is equal to 1.07. I said 1 plus because it's growth, right? 1 plus the rate equals 1.07. If I subtract 1, I get a rate of 0.07, which is equivalent to, with my decimal 2 places, 7% growth. How often does this happen? And again, frequency, we've talked about for days now, is how often something happens. And t is modeled in years. So this happens every 3 years. Okay, I'm going to put years up here since they recognize that in years. So this tells me this population of 1,250 is growing at a rate of 7% every 3 years. Let's try example 2. The following exponential function models the growth of a U.S. city, again, where t is measured in years. Okay, so let's take a look at this. Our initial population is at 350,000. Growth or decay, so I'm looking at the b value attached to the variable, exponent variable. This is definitely less than 1. So decay, again, it's between 0 and 1. Now, what is the rate? Okay, so this time I'm going to say 1 minus the rate is going to equal 0.95. I'm going to subtract my 1. So I have a negative rate equals negative 0.05. So the rate is 0.05. Which is equivalent to 5%. So this, decreasing, just to be clear, this population is decreasing at a rate of 5%. How often? Every 6 years. Okay, so again, hoping these are fairly obvious to you now, whether we're growth or decay, and how often something's happening. And again, I'm just going to label that years. All right, great opportunity to try number 3 here. So take a moment, read this to yourself, pause it, and then turn it back on in a minute. All right, see how this compares to yours. My initial values, 127,350. This number attached to the x, the b value is greater than 1, so I said growth. It's greater than 1. The greater than is pretty obvious to see how much bigger it is by 1. It's the decay that's not so obvious. But I'll write out my formula anyway for those that are still struggling with that. 1 plus the rate is this value, so the rate is 0.275, which again, we move the decimal 2 places to get a percentage, 27.5%, and it's happening every 12 years. Okay, so now let's write our own equation here. It says write an exponential function to model this scenario. A population of 28,000 is growing at a rate of 13% every 5 years. Okay, so they give us all the information we need. We need the initial amount. We need to know if it's growth or decay, which it was very blunt, says it's growing. 13%. What does that make my rate if they say 13%? I'm not using 13, I'm using 0.13. I know my initial amount was 28,000 and it happens every 5 years. So I'm going to say P of T equals, and again, you could call it F of T, whatever you want at this case, P for population, is 28,000. Growing, I'm going to say that's 1 plus 0.13. Every 5 years would be T over 5. Now, if you want to clean that up, that would obviously be very intelligent. So I'm going to say P of T equals 28,000, 1.13 to the T over 5. All right, let's do the same thing. We're going to do example 5. Read it to yourself. Jot down your pertinent information. Let's pause it and then turn it back on in a few moments. So go ahead and pause. All right, let's compare. So my population, P of T, started with an initial amount. So when time began, I had 152,000. It's decreasing, so immediately going 1 minus my rate, 8%. So again, you're moving your decimal 2 places to the left. So here's the decimal at 8. I need to count 1, 2. So 0.08. And it's happening every 12 years, so that's T over 12. Okay, and then I'm going to clean up inside there to say that's 152,000. 1 minus 0.08 would be 0.92 to the T over 12. So think about this. If it says decreasing, you better make sure that B value is less than 1. Less than 1, which should make sense. Okay, now that was kind of a recap of what we've been talking about. We are on to this big word of annual. Okay, annual. What does the word annual, I think it's on the top of your paper. It must have just jumped to the bottom of mine. The word annual means how many. That is the question of the day. Annual means how many. So if something, your birthday happens annually, it happens once a year. Okay, annual means 1. So in order to identify the annual rate of change, the coefficient of T must be 1. The coefficient of T must be 1. Okay, so we're going to go through a few examples. Question 6. A lot of times on this exam, they're going to ask you to change maybe from how often something happens to an annual rate, or an annual to how often something happens. So this first example, okay, we know this is our initial amount. So I'm just going to be clear on that. I'll put my I there. This tells me this function is increasing. So let's say P of T is increasing. Okay, can we do that percent in our head yet? At what percent? This is greater than 1 by 0.06, so it's increasing 6%. How often? And we'll just, for the whole sake, let's just say T is measured in years. Increasing at 6% every 2 years. Okay, now that's not the question. The question wants to know the annual percent. So again, annual means 1. How is it changing after 1 year? How is this changing after 1 year? So we have to manipulate this equation. And here's the deal. I want you to kind of bubble in your exponent here. It says, in order to identify the annual rate of change, the coefficient of T must be 1. Okay, I want to rewrite this. So watch how we're going to rewrite this. We're going to say we have 1,500, 1.06 raised to a power. Okay, now think about this. Dividing by 2 is the same as multiplying by what fraction? What number's in front of this T, of course, is a 1. So do you see how we have a 1/2 here? I'm going to rewrite this as 1/2 T. Dividing by 2 is the same as multiplying by a half. Okay, so now I'm going to box this in. I want you to do the same. We need to figure this number out. Order of operations, parenthesis, exponent. I want you to figure this out. So you're going to grab your calculator. And we're going to type in 1.06 raised to the 1/2. Okay, so what this is going to tell us, let's rewrite our equation. We have 1,500, and this just became 1.0295630014 raised to the t. We now have 1t. So now we have the annual per year, right? This is happening once per year. So I can now say P of t is increasing. Okay, notice this is still growth. It's greater than 1. I'm going to move my decimal 2 places to the right. So it's increasing at 2.956% every year. Okay, so this is a super important concept. Let's talk about what we just did. We took a rate that was increasing every 2 years and turned it into a rate that is increasing every year. So every 2 years you're making 6%, but every year you're only making 2.956%. Now why isn't it 3 and 3, right? Here's why. When you put money in the bank and you earn this interest, you now have accumulated more money. So now, based off your new amount, you're earning the interest on that, based off the new amount of money you have, you're earning interest, not off the original. Okay, so we call this every 2 years, and now we're to the annual rate. And our goal is really to go back and forth on these. This is a big part of our multiple choice questions that you'll see on this exam. Let's go ahead and try B. Let's just write out what we have. Okay, so we have initial amount. All right, is this growth or decay? Okay, so P of t is growing at a rate of, what's our growth rate here? It's greater than 1 by 28%. Now how often? And we said t is measured in years. Every 5 years. But the question doesn't want to know how it's growing every 5 years. It wants to know its annual rate. How is it growing after 1 year? All right, so we have to manipulate. So let's rewrite this equation. So I have 160. I have 1.28. I need this right here. I need it to be a 1t, right? I need that t by itself. So dividing by 5 is the same as having the exponent of 1/5 t. Right? You can picture a 1 in front of every variable. That is 1/5 times t. I'm just rewriting it differently. Okay, so now grab your marker, pen or whatever, box this in. We need to figure out 1.28 to the 1/5. Okay, so I'm using my calculator. I'm going 1.28, whoops, raised to the 1/5. And I am getting 1.050611122 raised to just the t power. So now I know that P of t is still growing, right? Still greater than 1, growing at a rate of, move that decimal 2 places to the right when it's growth, 5.06 every 1 year, or annually. Once means annual. Okay, so it grows 28% every 5 years, but every year it's only growing 5.06. Okay. All right, great time to pause and try C on your own. So I want you to do the same thing. Describe what you have here. So just take a moment and describe what's happening into P of t and how often it's happening, and then convert it to annual. Convert it to annual. So I'm going to pause the video, you pause your video, and turn it back on in a minute. All right, so hopefully we're ready to talk this out. I said P of t is growing at a rate, this is greater than 1, so a great, move that 2 to the right, 42% every 15 years. Okay, so again, the question says we want the annual, we want it to be every 1 year. So I need to get this t to be a 1. So I'm pulling this fraction out as a 1/15. There's a 15 on the bottom, which tells me it's a fraction, 1 on top. So I rewrote 1.42 to the 1/15th, typed just that piece in my calculator to get this number. Now I have t, an annual amount, right? Every 1 year. So I said this is growing at 2.365%, however you rounded, that's fine for now, every year. All right, now, in this extra space, if you've got it, or even at the bottom, wherever you've got room here, I want to throw another one up there that we haven't talked about yet. Those were all very similar. So let's call this one D. Let's say our function is now P of t, and this one's different. Let's say is, I don't know, 200 times 1.03 to the 4t. 200 times 1.03 to the 4t. Okay, well that's not a fraction, so that doesn't look like the other ones we've talked about, which is exactly why we wanted to talk about this. So let's get the easy part out of the way. Initial amount is 200. It's clearly growing. So I'm going to say P of t is growing at a rate, okay, 1.03. So my rate is 0.03, which tells me that's 3%. Now, how often is it growing? What does this say? Okay, if I said 4 times t, and t is measured in years, 4 times t, and t is measured in years, I would read that as 4 times a year. Not every 4 years, like these other fractions represented, right? This represented every 2 years, every 5 years, every 15 years. This one's different. This one says 4 times a year. Okay, 4 times a year. So picture this, you get a grade in your high school classes 4 times a year. Okay, P of t is growing at a rate of 3% 4 times per year. Now I still need to make this annual, right? So I'm going to rewrite this function. P of t equals 200. I have 1.03, really just to the 4 times t. So I'm going to box this one in this time. I'm just going to take 1.03 raised to the 4, and then this t will be all by itself. So I have P of t equals 200. So I'm now going to take that 1.03 and raise it just to the 4th. I don't need a fraction because this isn't a fraction, right? And I'm going to say that's 1.125508, etc., to the t power. So this is growing at a rate of 12.55% every year. Okay, so it's growing 3% 4 times a year, not every 4 years, 3% every 4 times a year, which is 12.55% every year. All right, so we are guaranteed to see at least one of these questions on every exam. So there's been, 18 exams. I have at least 18 of these. They pop up pretty frequently. Unfortunately, I chose 2 very similar questions where they're a little different on each exam. So we'll play more with them over the next few days just because they're so common. And if I had to pick like the toughest question of all, this is by far our most missed question in the high school over the past number of years, converting between these rates and annual rates. So it's definitely not an easy topic. They're wordy, and you really have to slow down and appreciate the question and try to decipher it for yourself. So let's take a look at this first regions question. Stephanie found that the number of white-winged crossbills in an area can be represented by this function, where t represents the number of years since 2010. So I'm just going to rewrite this for myself down here so I can kind of talk it out. And t is measured in years, and I'm always going to put that in there. which equation represents the total number of white-winged crossbills in terms of the monthly rate? Okay, so they want me to go from this one that's in annual. How do I know it's in annual? Well, remember, annual means 1, and there is a 1T here. So let me make a note. This is an annual, right? Because there's a 1T. And they want me to convert this to monthly. So obviously, as I look at these choices, they all have something to do with a 12 except this one. Okay, and monthly kind of makes me think 12. So let's kind of break this down. This one says that this is increasing, this is growth, right? Because it's greater than 1. This one says it's increasing at 0.643 every year. Would you agree with that? I move this decimal 2 places, 0.643 every year. T is measured in years. Does that have anything to do with monthly? Like, to me, that's the most obviously an easy one to eliminate. This has nothing to do with monthly. Okay. Now, what is the difference between these two? This one says it's increasing by 0.643 12 times t, and this is 0.643 t over 12. Okay, so I'm going to start with C here. This one says it's increasing by 0.643 every 12 years. Every 12 years. Right, that's what t over 12 means. Number 2 says it's increasing by 6.43. Now remember, when I multiply by 12, that's read 12 times a year. So this is 12 times a year or every 12 years. Which one to you means monthly? 12 times a year or every 12 years? If something was going to happen monthly, would it happen 12 times a year or would it happen every 12 years? I'm hoping you're eliminating every 12 years. That would not be monthly. Monthly would be 12 times a year. For t plus 12, that just doesn't make any sense. Okay, now let me go back to why I like choice 2 here. I want you to circle this and bring it down here. Okay, let's say you weren't sold 1.00643 to the 12t. Here's what I do for backup if I'm not 100% sure. I think this is it, but I'm not 100% sure. I can turn this into annual real easily. All I have to do is take this number and raise it to the 12. Box it in for yourself. So I'm going to grab that calculator, 1.00643, and I'm going to raise it to the 12th. And I get 1.079948 to the t. And if I compare that to what this original one is, man, it's pretty darn close. 1.079, 1.08 to the t. I'm feeling, 99.9% confident that's the same thing. Now, just for fun, maybe I thought it was choice C. This time, I would take that number, that 1.00643, and I would raise it to what fraction? This would be a 1 over 12. And I get 1.0005, which is not close at all. So I am pretty confident in choice 2. Okay. All right, let's try another one again. I picked 2 really similar ones. I apologize for that. I'll get to a little more diverse questions over the next few days. A study of the animal population of the red-winged blackbird, they really like their birds here, in Fort Mill, South Carolina, shows the population B of t can be represented by this function, where t, here's the important part, t represents the number of years since the study began. So this equation is in years. So again, I'm just going to jot that down. T years. In terms of monthly rate of growth, the population of red-winged blackbirds can best be approximated by which function? Okay, I want to know which one is the same. Okay, so they want annual and they want monthly. So I'm going to kind of do the same thing. I'm going to say, well, what the heck does this mean? This one would be a 1.2% growth every year. Does that have anything to do with monthly? Of course not. This would be a 1.2% growth, not every, 12 times a year. 12 times a year. This would be a 16% growth 12 times a year. And this would be a 16% growth every 12 years. Okay, so I first kind of decipher what they mean. So again, which one, I think we can narrow out two out that don't have anything to do with monthly. I don't think option 1, every year, has anything to do with monthly. And I don't think every 12 years has anything to do with monthly. Okay, I think it has to do with 12 times a year. So here's what I'm going to do with choice B. I am going to type this rate in and make it an annual. So I'm going to go 1.012, so do the same thing, and we're going to raise that to the 12th power. And when I do that, I get 1.1538. Oh, that's pretty darn close to what it says the rate should be. Now I'm going to take choice 3, 1.16, and raise that to the 12th. 5.93. Not even close to what the annual should be. Okay, so I'm definitely going to go with choice 2. So this is what I mean between converting from monthly to every 12 months to annual. We want to be able to go back and forth. Okay, now I've got another trick for you. All right, so stay with me because this is going to be really, really helpful when it comes to these exam questions. I'm going to argue that your calculator can do most of this for you. Okay, so watch this. I want you to think about this. Whatever I choose here, it says this is can be represented the number of years, right? So this is my annual form. And it wants the same equation, but in the monthly form. I'm looking for these two equations to be the same. So everybody grab your calculator. Let's type this original 1 and y equals, 750 times 1.16 raised to the x. Okay, so again, I'm trying to teach you a nice method to help you on these regions questions. All right, this is the annual form. Now, one of these should be the monthly form, right? Now, in theory, they should be the exact same. So, in y2, let's put our choice 1. 750 times 1.012 raised to the x. And y3, let's put the next equation. 750, 1.012 to the x. Whoops, that should be 12x, sorry. And y4, I'm going to put the third choice, raised to the 12x. And y5, I'm going to put the last choice. And I missed my decimal, it looks like here, 1.16. All right, take a moment, see if you've got all 5 typed in and they look good. All right, now we can start on a Zoom 6, of course. And it should make sense that we don't see anything. Okay, but this is where we need to be smart test takers. All right, we have to understand our exponential function. So Zoom 6, I see nothing. Well, I might see something. Not a lot, but I see something. All right, mine's still spinning, so I'm going to hit on to stop it. You can do the same thing if it's still spinning. Now, again, this is what a good test taker is going to do. You're going to solve every equation you can on your calculator as well. The initial amount on each of these is 750. So I'm not going to see what I want to see till I'm at least 750, right? So I'm going to immediately hit my window, do the same. And we know we can't see anything to 750, and we know it's growth, so it's only going to go up. Let's make our y max 1,000. And you got to stare at these as they go. All right, now you're ready to hit graph. My blue line is my annual one, right? Okay, that's choice A in red. Holy smokes, look at choice B. Just covered that up. Here comes choice C in pink. Here comes choice D in green. Which one annual and the monthly look the exact same? Well, certainly that blue one does, that second choice, which is exactly what we picked. So you can kind of use your calculator and graph all these choices to see which one is the exact same. So don't be afraid to use that method as well. So we've got some great practice on the next page for you. Oh, shucks, bad news again. You can't rip this page out because the back side is the start to our notes for the following day, when I will be back to see you all. So you're going to need a separate sheet of paper, and you're just going to have to write it all out on a second. You don't need to like recopy the whole problem down, but you'll probably have to copy, these sentences down here. So take your time. You've got time in class to start, and have a great day.